All right, people, beautiful people, welcome for joining me for this next half hour, 40 minutes. Thank you for your interest in Neo4j and in Kettle. My name is Matt Casters. I'm the chief architect of Neo4j Solutions, and I'm also the project founder of Kettle originally.
Yep,
Uh,
looks good now.
so
Thank you.
let's talk a little bit about this marriage between the two tools. I want to talk about what Kettle actually is, about what kind of integration points we created for Kettle and Neo4j, and also how Kettle is now using Neo4j. And obviously, I want to show you some examples. After that, we wrap up with the Hunger Games questions that you may already have seen in other talks, and then open it up for QA. So, what is Kettle actually? In short, it's a visual programming tool for data orchestration in the broadest sense. Yes? Oh, really? Yeah. Um, I will try to reshare my screen then. Hang on. Stop sharing and start sharing. Entire screen. Maybe I made a mistake here. How is this working for you guys? Can you see something? All good now? All right. Yeah, I think I just shared one application or something. So yeah, what is Kettle? The plugins, how we're using Neo4j, some examples, and then finish off with the regular Hunger Games and Q&A. So what is Kettle? A visual programming tool for data orchestration in the broadest sense. It is also known under the product name Pantao Data Integration from Hitachi Vantara. It's about 15 years old, and it carries an open source Apache public license, so very permissive license. We have a large community marketplace with all sorts of cool things, and Kettle is fairly easy to embed, install, package, rebrand, whatever. And you can download Kettle with Neo4j plugins and everything installed at kettle.be. And there's some documentation there as well, some links to the plugin projects and whatever. So that's an easy way to get started. And you can use it on very tiny computers and also very big ones. And we'll talk a bit about that later on. Obviously, I tried to run it on my Raspberry Pi, and you can run a Kettle locally on your in a full client on your laptop or also in your browser. And so yeah, it's starting to become more like a stateless machine that you can use in all sorts of circumstances, right? And we're using it in our solutions team as a sort of like a reference architecture base to get started for the complex stuff, for loading stuff into Neo4j. And why are we doing that? Well, we want to move faster, start rolling out solutions faster, and to reduce the cost in the meantime. And the cost over time is usually then uh, your maintenance cost, right? Changes, stuff like that. It really answers the build or buy questions. You don't need to buy a kettle, you grab it off the shelf. And the ramp on time is pretty low for developers like you, for technical people like you. A few days usually suffices to get started, right? All right. So, what are we like architecturally? Kettle is a metadata-driven, engine-based tool, pretty much like Informatica. So no code is generated at any given time. You just define what you need to happen. Uh, a read file, read a database, load some data in a node in Neo4j, and you can use a GUI for that. But you can also use code or rules to set up these jobs, these workloads. Right? It's clear, it's self-documented basically in the GUI. And we support two types of work. In general, jobs, which are the workflows, sequential series of things that need to happen. copy some files, FTP something, mail something to an operator, and transformations which describe parallel data streaming loads. And so 100% of all the options in the engine that we have built is available through user interface elements. And we have plugins for just about everything. Everything in Kettle is built around the idea that if there's a piece missing in the stack, and there always is something missing because every company is different, you should be able to write something yourself and join in on the fun. So we also built integration points for others to be able to run transformations and jobs in your own code. And the general idea is to allow our users to avoid programming anything because of the associated cost, the long-term cost of doing that. But since that is an impossible task, we allow the users to program in anything. So any kind of scripting language is fine, even Java. Another, there's a lot of stuff, a lot of scripting languages. And we also believe that transparency wins in the end. So we really go with very fine-grained logging, data lineage, execution lineage, debugging, breakpointing while we're loading data, pausing at a certain point, showing the data in a certain step, for example, data previewing. Row sniff testing, for example, allows you to see data that passes through a complex transformation in real time by scrolling the rows in a window. Stuff like that has made it quite easy to debug and see what's going on. Other cool options that are available to you is a complete UI for Spoon, the user interface for Git integration with that. WebSpoon is our web interface to the full user interface of Kettle. We have built datasets, a plugin for building transformation unit tests to do either test-driven development or simply testing the transformations that you already have, securing them for the future. On the big data side and on in general, we integrate with Apache Virtual File System, Apache VFS. It has a lot of protocols out of the box, so every step and every component in Kettle that references files, for example, is capable of reading files directly off of web servers, off of FTP locations, inside zip files, that sort of stuff. But also straight off of a Hadoop file system, off of S3 or Google Storage. And Hadoop support for Cloudera and the others is done through a compatibility layers, the shim layers, which work fine and which shield you from compatibility issues you might otherwise have between the various distributions and versions. And also something I wanted to mention is Kettle Beam. Kettle Beam is using Apache Beam to execute our transformations on Apache Spark, Apache Flink, and Google Cloud Platform Dataflow right now. Those are the three main big engines. And both transformations, streaming, and batch mode on all these three platforms. So this is the tool set in general. So we have Spoon, as I mentioned. This is the graphical user interface. Drag and drop, clickety click. We have a bunch of scripts available to you to launch your transformations that you built, which are just XML files basically, right? And you can run those scripts then in a scheduler, anything that you want. And you can run them locally on a system, but also remotely on a remote server. We also have Java API and SDK available for doing that, for doing all that sort of stuff. A standard file format, which has been standard since version 1.0, 15, 16 years ago. A rich plugin ecosystem. We also built Docker images for you in case you want to run the WebSpoon image, for example, on Docker Compose alongside Neo4j. We have the scripts and the things for that. There's a bunch of documentation, books, all of that out there. So this is kind of like the architecture that we're looking at usually. Our stuff is all stored, our metadata is all stored in Git, and you check out a certain version, and then you could run that using the Kettle runtime on a virtual machine, real hardware, on Docker, anything. And so this gives us a very clean system for doing uh, development, test, acceptance to production movement. We're also doing uh, the unit testing on Jenkins, or even doing continuous integration tests. It's all fine working with a simple tried and true system like this. Yeah. So let's talk a little bit about the Kettle plugins for Neo4j. And obviously, one of the first ones that we wanted to have is a cipher step. And the cipher step allows you to read and write. Read from Neo4j using cipher, but also write to Neo4j, and it supports things like dynamic cipher, where cipher comes from previous steps in a chain of commands, and but also does unwinds and stuff like that. It's tuned for high performance. You can call procedures. It's your get out of jail for free card. In case nothing else works, you can always use this one. And we also have something that doesn't require any knowledge of cipher, and it's the Neo4j output step, which allows you to create one node, two nodes, or two nodes in a relationship. Very simple. And that one is also fine-tuned for performance. And I will show you a demo for with this for parallel node loading, for example. And it also supports dynamic labels, so a label for a node can come from a previous step in a transformation, and it can actually be different from every row that you pass through it. Although that's suboptimal for Neo4j performance, but it is possible. And then we started building the Neo4j graph output step, which updates part of the graph, and it uses a logical data model, and I will show you an example of that in the demo later on. So basically, a logical model, meaning that it's just a description of the nodes, their names, primary keys, the relationships between them, and then all we need to do is map input fields coming from a variety of sources, any database on the planet, any relational database on the planet you can use for that, or files, or Mongo, or big data source, and then you can just bring it all together and map those fields to the model, to the node properties and the relationship properties. And what it will do is automatically generate a cipher for it. So this is really cool because it also takes into account missing data points. And I will show an example of that later on. For the workflow parts for our jobs, for people that like to have a defensive setup, we have job entries, we call them, components that check, for example, if a host is up and running. So you have a ping, and if the ping is fine, then you can test the Neo4j connection, and that way you can, if something goes wrong, once in a blue moon, after 2 years in production, something goes wrong because the network is down, or because something horrible happened, then at least you know immediately what the cause is. And so that's why we wrote this one, so you can check whether or not your connection is up and running. And obviously we have in those workflows, sometimes it makes sense to, I don't know, create a geospatial something, call an APOC, call a stored procedure, create an index, drop an index, that sort of stuff. And so we have one entry in the workflows for that as well. It makes a lot of sense. And since the end of last year, we also have the ability to generate CSV files for Neo4j import, because that is still the fastest way to load data into your Neo4j. And it uses the exact same steps as as I showed you earlier, but these steps now have the ability to output a graph data type. So Kettle now has a native graph data type, which can contain more than just JSON or something. It's really a native set of nodes relationships. And what this step then does is say, okay, for all the nodes and relationships in here, I'm going to dump the data into CSV files, which are suitable for loading by Neo4j import, right? And so it handles escaping, quoting, any kind of nasty data. It will swallow it, appropriately escape it, quote it, whatever. So you don't have to worry about this. The output of this step is a bunch of file names, usually in the import folder of Neo4j. And sometimes if you have multiple nodes and relationships in a graph data type, it makes sense to split them apart to run a unique query on top of it. So you can say, okay, I want to have unique values so that my node loaders don't choke up. It's always faster to do these things in Kettle in a parallel sort, something like that, and then have a unique set of values. And then obviously once you have a list of file names, you can pass them to the Neo4j import command itself. For some people like me, figuring out what the right syntax is not always trivial. So this one does this for you. It automatically generates the appropriate Neo4j import command for all the files that you want to load, for all the nodes and relationships that you want to load. All right. Now I want to talk a little bit about one of my pet subjects, and this is logging, right? Uh, in general, I think we fail to answer a bunch of questions about our data, and certainly on the data integration side, you can ask questions like, when was the last time my graph was updated? When was the last time this node was updated? And where is this node information coming from? How was it executed? Which job or transformation was responsible for that? Etc. Etc. So we started writing a logging plugin for Kettle. It's quite easy to write these plugins, and so this writes all the things that Kettle does, all the execution, Linux graph, but also a bunch of metadata into Neo4j. So, and execution details are stored on a job entry, transformation step, database level, very fine grained, and it also stores those places where we know that the graph got updated. So if a node gets created or updated, we keep track of that based on the label, not on an individual node level, but on the label level, so that we can say, okay, which transformation is responsible for the update of a customer node label, for example, and then we can just ask Neo4j that. Right? So this is how this works. I will show a demo of that later on. But these transformations, these pipelines, data pipelines, they get logged into Neo4j, the execution, and you can basically that this transformation is part of a bigger job that does all sorts of updates of other nodes as well. So in which order was this executed? Of which workflow was this part? This all gets logged into Neo4j, and you get a clean view of that. So what can we do with that? So obviously we can examine past executions. If something went wrong over the weekend, you come in on Monday, you can immediately see, okay, let's take a look at the log. You can see how long something took. You can imagine, examine log text, and you can actually generate your own, use your own cipher queries to see what's going on. But you can also calculate delta windows, and this is important for delta incremental loads into Neo4j. Suppose that you source your data from an Oracle database, for example, and you want to have, you do an update every day. So what is the appropriate date range to get all the new changes since yesterday? Well, actually, that story is quite complicated because you need to go back 2 days if last night failed, right? And so, in general, we need to take the last execution without error into account. That problem gets solved with a dedicated step, get Neo4j logging information, and from top to bottom, if then you open the job that failed and it has a gazillion sub jobs and sub transformations. Well, they're hard to debug, even in the best of tools, and so. Um, since we have Neo4j at our disposal, we can find the shortest path query from the last execution of that job to the lowest execution node without children, with errors. And I will show you the query in a bit. It's quite simple. And Neo4j finds these paths in split seconds. It's really cool. Um, so this is how this looks in a complex job, and there's some error that happens. It's nice to see it in red, but it doesn't really help you because the logging text is flat, right? It doesn't. It just shows you something happened, but where did it happen? In which part of the job, and also in what execution order did it happen, right? And so now in the GUI, you can just say find the error, and you get the whole execution lineage and the path to the error. And you can actually click on fix the error in this case in the demo, and go to the step immediately and fix the error immediately in the transformation. But you can also ask from the bottom up, how was a component executed? You know, if you're working on a low level transformation, how was this executed the last time, and what kind of shortest paths, what kind of path were taken to get to this point. And for highly dynamic conditional executions, this is very handy. It's the same kind of like idea, but that's from the bottom up. And yeah, you can also examine obviously the executions with Neo4j browser or Bloom. And we generate the cipher statements that we use to show the results for Neo4j beginners, of which there are a lot in the Kettle community. So for Kettle users, this is a fun Neo4j learning path. This is something that I want to expand into more like an audit graph, and since you can add data profiling, but also Git branch commit revision history. With a similar purpose as the other, maybe we can find the shortest path between a recent Git change and a failure of a run, right? And maybe there's a correlation there. Maybe somebody checked in something they shouldn't have on a Friday night at 4 o'clock, and then we can search the guilty, right? But transformation unit testing results from Kettle as well, we can store in there. The transformation data lineage itself, we have that available as well, so we can add that as well. So stay tuned for that. We're working on that. So let's, in my last 10 minutes or so, let's dive into some examples, right? Let me just give you guys first a quick introduction to Spoon itself. Spoon can be started with scripts. It runs on in full client on Windows, Linux, and Mac OS X, and it also runs in your browser. So yeah, if your sessions don't time out. Okay, so typically how this works is that on the left hand side you have a whole palette of different steps that you can use. So you have steps and job entries. The job entries always start with a start entry and then follow certain paths, right? Maybe something went wrong here, and then we can send off an email. In general, the green arrows are followed. This is successful, then do the next, then do the next, then do the next. And you can simply add or remove job entries by saying, okay, maybe if something goes wrong here, I want to send off an email, and then you can connect the two. There you go. And clicking here makes it unconditional green arrow on. Okay, so this is very simple. So you have a whole palette of different conditions. Like I said, check if a Neo4j connection is available, and if not, maybe send off an SNMP message, maybe alert Nagios, maybe send an email. It depends on the situation that you're in. But it makes it clear to see what's going on. And again, we have hundreds of these kinds of things for all sorts of purposes. And similarly, this is a serial sequential kind of deal for loading customers, for example. We have a parallel engine, right? So in this case, we have an icon which represents the CSV file input step. and it reads from a certain file in a relative path. The columns are defined. We can preview the data and see what's in there. This is just test data. And so once we're done with this, we have a bunch of output fields here, rows of data, that we can then use in the next step. In this case, the Neo4j output step. And this is an example of how data is parallelized. So in this case, we decided to start 4 different copies of a certain step. But this is configurable. You can make this a parameter. And in this case, we can look at the step metrics and say that, okay, there's 100 records that came out of the CSV file, and they're split up in the round robin system across the 4 different step copies of 4 different threads. So in total, we had 5 threads running in parallel in this example, right? This is in general done by creating mini pipelines, row sets between the various step copies in general. Kettle supports not only like round robin data passing, but also things like partitioning. So if we have a partitioning schema, for example, where we use remainder of division in a 4-way partition schema, and we use the ID to partition, now the same customer with the same ID will end up on the same step copy. That's guaranteed with this algorithm. And this is no longer just haphazardly distributing the rows, but really targeting the various step copies. This can be helpful, for example, with certain transactions, certain caching mechanisms, with group buys in parallel, for example. Those kind of things are part of that toolbox, right? All right. So yeah, maybe I will wrap the introduction to Spoon up here. Uh, Please feel free to ask more about this in the questions area. In general, we find that people just get along quite quickly. Maybe as a final note, so in your data integration folder that you have that you download, there's a bunch of samples that we for transformations and jobs, literally a whole list of them for all the various steps out there. But we pack out also the plugins that I'm showing you if you download this package. So load nodes, update the graph, and these samples are packaged in with the zip file as well. So you have them at your disposal. Simply open them up and use them. Maybe as a throwaway for Kettle, I'm using environments to switch between the various projects I do for customers, for proof of concepts, for the work that I do for Beam, for example, for my telco colleague, stuff like that, right? And it makes it very easy to jump between the various projects. It remembers all the open tabs. You can set up various parameters. So like all my Neo4j host names are all uh, parameterized so that you don't have to hard code anything and you can easily move from one environment to another. So make sure to use that and set that up. Now let's get back to the presentation. Yeah, the next demonstration was the Neo4j output step, reading things in parallel. You can actually read a CSV file in parallel as well. I haven't demoed that, but loading the data in parallel is possible as well. Updating graphs with the graph output step is pretty interesting as well, because it tries to solve a problem. But this is a cool example in the sense that it's a demo from Rick van Bruggen that I keep using because it has data quality issues, and data quality issues in the sense that there are like superfluous asterisks in the data set. I don't know where it comes from. Um, so when we're processing this data, um, you can actually click on the step to see what the data looks like. So in this case, with an asterisk. In here we use a regular expression to clean that up and the asterisks are gone. In here we duplicate the rows so that we have different rows for the various beer types. so a normalization exercise. In here, we convert percentages to numbers, the strings, and in here we add a strength evaluation, high, very high, low percentage alcohol. Because for Neo4j, it's easier to follow the relationship to those nodes than it is to query the index on, for example, alcohol percentage, right? And so finally, when we have all this data available, we can load it into our database, into our Neo4j instance. And the way we did this is by modeling the different nodes in Neo4j. Uh, they're just logical information, but we define what the primary key is for each node, and then we also define relationships. And we can give descriptions and labels and source and targets. And this is how this looks a little bit clunky, but my colleague is working on a better tool for this. But in any case, so once we have a logical model, all we need to do is simply specify which field goes to which node property, and Kettle will then automatically generate the merge statements appropriate for this. Because in our case we have 5 possible output nodes, but in case we don't have a relationship with, if we don't know the beer brewery where beer is brewed, then we can't make an unknown relationship or something like that. That's not doable. So we have for 5 nodes, 5 nodes to update, or 4, or 3, or even 2, or just 1. And the relationship's the same thing. Sometimes the same thing. Sometimes we just simply don't have data, and then we don't have to create a relationship, right? And if you want to program this, it's a lot of if-then statements, and it grows exponentially with the number of nodes that you want to do. So this step is maybe not the most performing one, but it does a lot of stuff in one go, and so it's not the slowest either, because it can do a lot of updates at the same time. And finally, something I also wanted to mention is that you can also read from Neo4j and use that data to populate, for example, an Excel file, right? In this case, simply we have we read the data from Neo4j back in, what we just uploaded, and we want to write this to an Excel file. We do an aggregation method again. We add the commas back into the beer types. We do a sort by strength, and then write it to an Excel file. These kinds of things are interesting for doing like the last mile integration with third-party tools. Maybe you have a reporting tool. Maybe you want to generate a Tableau data set. Maybe you want to write to a MySQL server somewhere. The result of maybe a recommendation, a query, a shortest path that is hard to figure out for other tools. So you can do that with this. All right, I'm over the half hour, so that's good. To wrap up, some takeaways. So yeah, use data integration for Neo4j using Kettle to work faster and tackle harder problems. Don't use it to load a CSV file into Neo4j. By all means, use any kind of other load CSV script. That's fine, right? But once you go beyond that, once you go with multiple data sources, and yeah, then Kettle is a great option, and you can reduce the risk for you and your customers by seeing whether or not it works faster. Failing faster is something that has value as well, but succeeding faster obviously as well. And obviously, you can govern your Neo4j solutions using Neo4j, make the whole process, the data loading process, more transparent, and answer more questions about the data when it was uploaded. I also take the opportunity to invite you to the Kettle Community Meetup in Antwerp on November 23rd. Neo4j is sponsoring the beer, and so we have a bunch of sessions about Neo4j and some practical use cases. So some cool names. So make sure to visit the website. The website expands to this, and you have all the information about when it's happening and what's going on. And yeah, I think I'm almost done here. We have our own Slack channel, kettlecommunity.slack.com. And so, yeah, the Slack stuff is kind of clunky, but you can just mail me if you want to invite, and then I'll just send you an invite. So feel free to join in on the fun and see what we're cooking. Now, I've been told to allow you to answer a few questions, Hunger Game questions. So I'll have to forward you to r.neo4j.com/Hunger Games, and the questions are all, they told me to figure out hard questions, but they're all easy, right? Can you extract information from relational databases using Kettle? A, no. B, yes, but only a few. And yes, C, almost all of them. The second question is, can I script harder parts of my data orchestration work? No, Kettle is a visual programming tool. Yes, you can use all popular scripting languages. And yes, you can use JavaScript. And the third one, can Kettle work with big data resources? Yes, Kettle supports native support like protocols. Or yes, we also support Visual MapReduce. Or yes, we also support things like executional Spark, Flink, and Dataflow engines. And I guess I'll give you 5 minutes for that, or you have any idea, Michael, how that works? Yeah, let's open it up for Q&A. I am at almost the 40-minute mark, I think. Should I open the microphones up for people? So let's take a couple of questions here. So Rdf Data, right? Yeah, so we have a project. My colleague Jesus from the Telco group, from the Solutions group, my colleague, he has actually Cypher scripts and everything to import Rdf data. But I created an improved version for that for the large data set, because Rdf data is sometimes hard to digest. So what we do is we first take a pass at it and extract unique values for the various nodes that we want to create. Yeah, maybe it's a great topic for a blog post or something. But suffice it to say that yeah, we can import Rdf data, even larger data sets. Hello from Halifax. Hello back. What is the difference between Kettle and Pdi? So yeah, Pdi, Pentile Data Integration, is the commercial name. Kettle was the original project name. Does Spoon connects to server? Yeah, you can run locally in Spoon. So the runtime engine for Kettle is available everywhere that you have a runtime. But yeah, we do have a server that you can use, and that does the processing. What we do for certain customers is actually we don't use servers anymore. We use Docker containers, right? And the advantage of having the runtime in a Docker container is that unlike a server, you run something in Docker, and then when it's done, it just shuts down and everything is cleaned up again. The memory is available again for other things to do, and so that's another way of doing it. But yeah, sure, servers are available. Uh, can you discuss GeoKettle and the ability to perform spatial transformations? Well, GeoKettle used to be a project out of some Canadian university spin-off, and oh, they're on the Q&A tab. So let's go through this one. So GeoKettle stopped at some point, but the geospatial plugins are still available I think a French company revived them. So there are just plugins available that don't require Kettle at all. They're just run on the vanilla Kettle. You can just throw in there. Right? So take a look at those. All right, what's the difference between Kettle and PDI? I got this. How is logging analysis different from Splunk? I don't know. Uh, but I do know that I posted a Splunk input step for Kettle on my github.com/mattcasters uh, repo. So if you're using Splunk, you can use this to extract data from it and maybe load stuff into Neo4j. So you can access that information in Splunk using a query. What is the download link again? www.kettle.be. And so it's a mini site that I revived. You can download the Kettle Neo4j remix here. Here is a basic documentation package in Google Docs, and the downloads are here. Here's the log file. If you want to play around with Apache Beam and Kettle, there's a build here down here, and a link to the WebSpoon Docker image is also included here, and then links to the plugins. Let's take a look. So what's the easiest way to get started with Kettle and Neo4j? Well, just take a look at the examples. Um, you know, take a look at the documentation, the examples. They're all packaged in. You should be up and running in no time. It's really that easy. Is it possible to retrieve data from public API? So yeah, we obviously have steps like the REST step or HTTP client steps, which make it easy to extract information from a variety of sources. Is it cloud ready? Yes, very much. Since Kettle does not have an installation footprint to speak of, it's easy to see that if you don't have any need for installations like repositories or license keys and that sort of stuff, you can run it in any kind of Docker container. Some friends of mine even ran it in a Lambda, for example, in a serverless scenario by